I want to continue with our discussion of messaging on the AWS platform and what kind of services AWS provides to facilitate this. Another way of expressing it is we want to look at how we can achieve event-driven architectures on AWS. And there are many services, but we're going to restrict ourselves to two, which is SQS, which we looked at last week, and today we look at SNS. And there's an element of cart before horse because you've already practiced these things in the lab, but nevertheless, I'll step my way through it anyway. So SNS, again, it's quite an old service. 2010 roughly is what I'm getting when I Google it. So it certainly predates this serverless idea, but it is serverless in the sense that you don't have to configure any servers to run your SNS service on. And what SNS, which stands for Simple Notification Service, what it is what's referred to as, in the technical terms, a pub/sub service, a publisher-subscriber service. Now, how it differs from SQS is if you've got a scenario where you want to send a message to many consumers, although we don't refer to them as consumers in the context of SNS, we refer to them as subscribers, but let's use the language that we're familiar with first. If you want to send a message to many consumers, you cannot do that with SQS. With SQS, even if you've got many consumers that are listening to an SQS or reading from an SQS queue, when you put a message onto an SQS queue, it's really a case of whichever consumer gets the message first, they can process it, but all of the other consumers won't see that message. Now, when you've got a situation where you want all of the consumers to see the message and process it, then you revert to using this SNS service instead. And so a bit like SQS, though, with SNS, you've got an entity that is writing messages onto an SNS. We don't refer to them as queues, we refer to them as topics, but we have an entity that writes messages to SNS, and then we have entities that read messages from SNS. The writer, or the event producer, is referred to as a publisher, and the entities that are reading the messages and processing them are referred to as subscribers. And hence we have the term pub/sub, which is kind of an abbreviation for publisher subscriber. Now, on the subscribing side, there are lots of resources that could be a subscriber, and we've seen some of them in the lab again. So an SQS queue could actually be a subscriber. A Lambda could be a subscriber. Even a HTTP endpoint could be a subscriber. That kind of translates to API gateway could actually be a subscriber. So when a message is sent or published on a particular SNS topic or channel, then that message could be routed straight to an API gateway, and where it goes from there depends on what how you've programmed the gateway. You can have SES, or the simple email service, which you've used a little bit. You could have that as a client, and so the idea is the publisher would write a message to the SNS topic, and that would trigger the sending of an email to whomever. Or the subscribers could be an SMS messaging service or indeed it could go to a mobile notification service as well. The only ones we will use it on are SQS and Lambda as being the subscribers. In terms of the publishing side, what entities, what type of resources can publish or write a message to an SNS topic? Again, it's varied. Obviously, Lambda is one option. In the lab, what you're doing is you're uploading an image or a file or an object in the language of S3. You're uploading an object into a bucket, and the actual S3 service publishes a message onto an SNS topic. Equally, if you had some CloudWatch alarms, those of you that are not doing the CloudStream now may vaguely remember about CloudWatch alarms, but you could have a CloudWatch alarm. Once the alarm is triggered, that could cause a message to go on to an SNS topic as well. And there are other options. So both on the publishing side and on the subscribing side, there are a number of configurations that AWS supports. As with many of AWS services, there is what's referred to as in-flight encryption and at-rest encryption. In other words, messages that are written to, when a message is being sent from a publisher to SNS, over the network, the messages are encrypted as they're being transmitted over the network, and also the messages when they are being stored on SNS, they're stored in encrypted form as well. Sometimes you may want to only have a subscriber process certain messages, not all messages that are written to an SNS topic. And you can configure the subscriber to filter out messages that are not of interest to it. We'll see a little bit of that, how we do that later on. There's always a security element to AWS. So clearly, from the publishing point of view, the publisher has to have the necessary IAM permissions to write to an SNS topic. And so that involves using IAM policies. Again, fortunately, the CDK kind of takes care of generating those policies for us. If it's a Lambda, for example, oddly enough, I don't have any example of a Lambda writing to an SNS topic, but doesn't require much imagination on your part to work out how that might work. There's obviously an SDK, an SNS SDK. There's loads of acronyms involved here now, but there's an SNS SDK which a Lambda would use to publish messages onto an SNS topic. But again, it has to have the IAM privileges to do that. You can also associate what are called access policies with an SNS on the SNS side, and that kind of controls who can publish messages to that SNS topic, whether that be cross-account access, allowing an application running on another IAM account to access an SNS topic that is associated with, let's say, your account, your IAM or your AWS account. You'd have to configure the SNS topic to allow that. And equally, where, for example, in the lab where we've got another S3 service other than Lambda, for example, S3, for that to be allowed or permitted to write to an SNS topic, then the SNS topic itself has to grant those permissions. Again, a lot of this is familiar from this kind of structure is familiar to us now at this stage from other services that we've looked at, like SQS and DynamoDB and so on. There is auto-scaling built into SNS. I won't look at the auto-scaling side of it, but it scales up, and there's redundancy and all of that built into it. Sometimes SNS, let's say, when it's trying to send a message to a subscriber, it fails, either because the subscriber side is unavailable or is inaccessible from a networking point of view, or has crashed temporarily. So what does SNS do in that case with the actual message? Well, it does retry a number of times, but eventually it kind of gives up. But from an application's point of view, we don't want to lose those messages. So you can associate a dead letter queue, a DLQ. You can associate a DLQ with a subscriber. You associate it with a subscriber, and then the message that SNS could not deliver to the subscriber endpoint is put into the dead letter queue instead. And then presumably you've got a Lambda that's reading those messages and processing those in some sort of sensible way. And we'll see how to associate a DLQ with a subscriber as well later on. So I'm using the word topic here. Topic is also referred to as a channel. So what we do is we create SNS topics or SNS channels. That's the equivalent of creating an SNS queue. And as the image shows us, so on the left, we have a publisher or some sort of entity that's writing messages to an SNS topic. And on the right, we have what are often referred to as endpoints or subscribers to a topic. And I've already mentioned that the subscribers can be of a variety of types, as is illustrated there. And you can have many of them, and you can have a mixture of them. The CDK code, which we have already seen now, is pretty straightforward, really. You create your topic, so that's what we're doing here. We're creating our SNS topic. There aren't many properties that we need to set for the topic. I think probably display name is probably optional, actually, so you get away with not setting any properties. Then we have to associate. We don't have to, but presumably we want to associate a subscriber or an endpoint to that topic. And so that's what we're doing here. So there's this add subscriber convenience function associated with our topic. And here it looks like we're creating a subscriber that's an SQS queue. And this presumably is an SQS queue that I have defined elsewhere in my code. And you can invoke this add subscriber multiple times, depending on how many subscribers you want to associate with a particular SNS topic. And all I'm showing you here really is the different options that are available to you, which is kind of tallies with what I've been saying so far, that there are different types of subscribers. So when I typed the dot here, the VS Code's IntelliSense is telling me, look, these are the different types that you can select. Let's do a very simple demo. So my demo is on my publishing side. I'm just using the AWS CLI. It's going to publish a message onto an SNS topic. And I have a Lambda, which is the only subscriber to this topic. And we're just seeing excerpts of the code here. So that's okay. We've seen that before. That's how we create the topic. I've got my Lambda function, which doesn't have anything unusual in terms of its configuration and properties. And then I'm hooking up my Lambda as a subscriber to this topic, and I'm outputting the ARN of the SNS topic which I will need when I'm using the CLI. So if I flip over to VS Code, this is kind of the 101 example, we might call it. So if I go into my stack file, I have all the things that I've just shown you on the screenshot there. I've got a number of lambdas. The only lambda that's being used by this example, the lambdas don't do anything interesting. They just console log the event that they receive. And so the lambda that's being used in this case is this one here. So it console logs the event. Now I'm doing a little bit of validation checking here, which isn't relevant to this demo for now. So the only significant statement is the console log. And that's it. So I have deployed it a few moments ago. And based on the stack is outputting the ARN, which is this here. This is the ARN of my topic. And so if I want to use the CLI, the command, which I've stored here for myself, is this is how we can publish a message using the CLI. I just need to change the topic ARN part. So if I get rid of this, and substitute in my new ARN. And my message is a simple, oh yeah, I'm using my message is stored in a JSON file, which is, where's my JSON file? Here's my message. So just a simple JSON data structure. Hit go. And then if I flip over to my management console and check to see that there's a log stream there for the Lambda, if it has executed. And here's the log stream. And if I go into it, surprise, surprise, my Lambda has been triggered and the console log has produced this. And my message is, here's my message. Let's see. Probably staring me in the face now. Oh yeah, here's my message here. Okay, so that's fine. Just by the way, something I didn't mention, we've looked at these console logs lots of times, but if we just break down the console log, this is a Lambda thing now rather than an SNS thing. The init part here, that's telling me that this Lambda had to go through a cold start. You might remember a Lambda is loaded into a micro VM. And if it's the first execution of the Lambda, then the code outside the Lambda handler, which we call the initialization code, that's executed. And then the Lambda handler itself is executed. And then maybe the micro VM is kept for a short while, just in case there's another event that will trigger the execution of the same Lambda. So the init tells me here that this micro VM had to go through a cold start. It had to execute the initialization code, even though there wasn't any initialization code in my particular Lambda function. The start is where it started executing the actual handler function itself. Anything after that then is console logs that came from my handler. And the end is obviously when it's completed the execution. And then you get a little report. And if you actually look at the report for a Lambda, you get an idea as to how much memory it actually consumed, what its processing duration was. So the amount of memory consumed is an indicator that maybe you have over provisioned the memory for it. But I think we gave this Lambda the minimum amount of memory, so we can't make it any smaller. And the more memory you use, as you know, the costlier it is for the execution of your Lambda. Anyway, that's kind of by the way. So it looks like my simple demo worked fine. Surprise, surprise. Now, there is one gotcha. So the screenshot here is showing you the output of the console log of the event. And it seems to indicate, and this looks quite similar to the structure of the event that you get when a Lambda has been triggered by a batch of SQS messages. When we were talking about SQS, the way Lambda and SQS work is the Lambda service polls the SQS queue for messages, and if there are messages there, it will batch them and send a batch of messages to your Lambda for processing. Now, that's fine. And this seems to be indicating the same thing, because I've got it looks like here I've got an array of, in this case, SNS messages being sent to my Lambda. Whether there is only one entry in that array or not isn't important. But it does seem to indicate the potential for my Lambda to receive a batch of SNS messages. Now, it's misleading actually, because when I've read the docs on this, it turns out that for every message that is sent to an SNS topic, and if that SNS topic has a Lambda subscriber, which it does in our case, for every message that is sent to the SNS topic, there is a Lambda instance triggered for each message. So there's a one-to-one. So you don't actually have the possibility of getting a batch of SNS messages. That's why I've kind of written it here, but I've striked it out, because at least from my reading of the documentation, there is a kind of a one-to-one. Each Lambda, each message will get its own Lambda instance execution, if you like. Right. That has implications in terms of concurrency. So if you've got a high volume of messages being sent to an SNS topic and you've got a Lambda subscriber, then you could have high concurrency instances of your Lambda processing each one of those messages. So that's obviously a problem. So how do you solve it? You solve it by sticking an SQS queue in between the Lambda and the SNS topic. But we're just getting a little bit ahead of ourselves. Now, when you have SNS, well, this is kind of linked to what I've just been saying, but yes and no. A very common pattern that you see being used is SNS with SQS, where each SQS is feeding a lambda function, where each lambda function is doing some sort of processing of the message. But so the idea here is this, there'd be a lambda here and a lambda here and so on for each SQSQ. And each of them is doing a different type of processing, but they're all processing the same message. And the nature of the processing is such that it can be done in parallel. Clearly, if the processing done by this lambda has to happen before the processing done by this lambda, then you cannot use this pattern. But if that's not the case and it can be done in parallel, then you can set up this kind of configuration. And this is often referred to as the fan-out pattern. And you've actually, you've got an instance of that happening from the lab, if you remember. So now it doesn't have to be all SQSs feeding into a lambda. You could actually have a lambda here, SQS here and here. And so that would work fine as well. Now, why you would put the lambda here as opposed to over here, again, there are issues associated with whether you decide to do one or the other, and I'll talk briefly about that, but that is possible. So the notion of fan-out tends to be associated with this architecture, where there is SNS, which has been subscribed to by many SQSQs, where each SQSQ is feeding a lambda handler. And I'm going to have a short demo of fan-out, but it's not going to be your kind of traditional fan-out setup. In my case, my demo, again, I'm just using the CLI as the publisher. I've got one SNS topic, and I've got two subscribers. One is a direct lambda subscriber, and the other one is an SQS subscriber, which feeds a lambda as well. This lambda here now is not a subscriber though. This lambda is just polling this SQSQ, which we talked about last week. So it's the SQS is the subscriber. But the code, is kind of similar really. Again, we create our topic. We have a queue in this case. We've got a couple of lambda functions. We've got two lambda functions, and we do our subscription down here. So if I set up that scenario, which I'll do like this. And I'll do a redeploy now because it's the same stack as it turns out. And while that's redeploying, I'll just clean out my logs, which is just something that I do personally. You may not feel necessary, but I just go through the habit of cleaning out the logs, certainly when you're in debug mode, so that you don't accidentally read the wrong logs when you are doing your debugging. There aren't many logs in this case, but as I say, it's just a habit I've gotten into. Now, because I've added a second subscriber to my topic, which is the SQSQ. That's why, and that has added some security issues to my stack. In other words, the SNS access policy has to allow the SQS subscriber to take messages from it. So that's why I was asked to confirm whether I will allow that or not. Hopefully it will deploy quickly. In the meantime, well, no, I can't do it in the meantime, actually, sorry. Right, so I'm going to send the exact same message. And in this case now, I should get two log groups, one for the Lambda subscriber and one for the Lambda that's connected to the SQS subscriber. Both of the Lambdas don't do anything interesting. They just console log the message. So I can rerun my publisher, which is just the CLI. And if I go over to here and do a refresh, now there's only one log. There should be two though. The reason there's only one is because the Lambda that is linked to the SQSQ, there's a slight delay on that because I set, if I look at the code, I set, and this is really harping back to some stuff that we looked at last week. If I look at here's my stack. And again, we know what's in it now really at this stage. We have our topic, we have our queue, and you can see here, I set a 5-second delay on the polling that the Lambda service does of my queue. Yeah, so that's why when I refreshed here, I only got one log group popping up because the SQSQ hadn't been polled yet. But if I do a refresh now, I have my two logs. And, you know, what's the only one, if we look at the SQS one, so this is the log of the Lambda that's linked to the SQSQ. We looked at the other one a few moments ago in the other demo. But again, there's no great surprise. We will see our message buried inside there. Now this is a Lambda that is linked to an SQSQ. So the notion of a batch makes sense here. There's a potential for the Lambda receiving a batch of messages from SQS, where each of those messages is wrapping an SNS message. And so we can see in the body here, the body is quite big actually. Okay, which is what I'm going to talk about on the next slide. But if you look closely, you'll eventually find my original or source message is buried inside there. In fact, it's probably clearer on the slides. So what I'm showing you here is, no, I'm not showing you that. Oh yeah, what I'm getting or pointing out here is that SNS, when SNS has an SQS subscriber, you know, this is all a little bit, all these acronyms are, when it's an SQS subscriber, what SNS can do, but it's configurable, is it can take the message and wrap it in what we are calling an SNS envelope. And it's that then, that wrapped message is what's sent to SQS. And so the Lambda that's linked to the SQS, what it receives is the enveloped message, source message. and you just have to drill down into it. So I'm saying here that SQS wraps the source message. The source message is, in my case, the message that was sent from the CLI, which was my simple little JSON structure. It wraps that in an envelope, and the envelope contains information about the SNS topic that provided the message, if you like, and some other information from the SNS side. But I'm saying that that is configurable. You can configure the SQS subscription so that there is no envelope put around the message, because maybe your Lambda just isn't interested in it. And the way you do that is using this simple little configuration option that's available to you when you are doing the subscription. So what this option is a Boolean, and you set it to true or false. The default value is false. The default value is false, which means there is an envelope. If you set it to true, you're saying just I only want the raw message put into the SQS queue. I don't want the SNS envelope wrapped around it. And okay, in high volumes, it can be significant. So what I'm showing you in this screenshot is the message that is received by my Lambda, which has the envelope included. So the envelope is this outer ring box, whereas the source message is this inner box. So that's what you get, and that's what I'm getting at the moment, because if I flip over to here, that's what we're seeing here. This is the SNS envelope wrapping my source message. But if I simply go back to my source code, let's see, do I have it? Here we go. If I now enable that, save, just do a quick redeploy, hopefully quick. Clean up my logs. Probably overkill now at this stage, but can resend my message. Now it's the Lambda associated with the SQS queue, and there's a slight delay in that, as I mentioned. So let's see what the difference is. So here's my message body now, which just has the raw message in it. So it's reasonably significant in terms of the amount of data, certainly in high volumes of messaging going on. And that's what that screenshot is showing you as well. Okay, so we have two options. We have the option of making a Lambda a direct subscriber to SNS, or we can hide the Lambda behind an SQS queue and let the SQS queue be the subscriber. So, which do you go for? In most cases, I think it's the latter. It's the SQS plus Lambda option. And just giving you some advantages and disadvantages, mainly with the SNS directly to the Lambda option. The disadvantages there's no batching going on. So that could be a problem if there is a high volume of messaging entering into our SNS topic. And because there's no batching, there's also, you've no control over the Lambda concurrency levels, which we can control, if you remember, when we're using Lambda with SQS. So if there's low traffic, I suppose, then going from SNS directly to Lambda is fine. But if it's a high volume of messaging, then inserting an SQS queue is probably the better option. Also, you might remember with SQS, kind of built into the SQS to Lambda integration, there was this dead letter queue, which SQS managed for us. Now you don't have that option when SNS is involved. So we do need to handle errors that might arise with our Lambda throwing exceptions while it's processing a message. It has to actually take care of dealing with those scenarios. Whereas when SQS is involved, it takes care of us for us, as long as we've configured a DLQ. Now, I know I did say a couple of slides back that you can define or associate a DLQ with SNS, but it's more the responsibility of the Lambda side than it is of the SNS side. And I'll show you how to do that in a moment. So these points are making the same thing, really. But I guess it's the concurrency control and the lack of batching. That's the main downside of making the Lambda a direct subscriber to SNS. However, where this integration is probably a good option is where the actual speed at which a message is processed is important. So if you want to, if the messages are related to some sort of time critical event and you want that event to be processed as soon as possible, then going from publishing the event into your SNS topic and having the Lambda a direct subscriber of it, that's probably the better option in that case. Because as we saw even with the simple little demo, when we stick an SQS queue in between the two here, there was a delay in triggering my Lambda. So I guess for low volumes of messaging, but where the message is associated with some sort of time critical event, then taking this approach might be the best one. But in the majority of cases, the disadvantages outweigh the advantages. Now, SNS has a number of subscribers, and it has to deliver the message to the various subscribers. But what if it can't deliver the message? You know, what if the subscriber side is inaccessible, unavailable due to a network issue, or has temporarily crashed, or the subscriber is throwing an exception? If it's in the case of a Lambda, if it's throwing an exception when it's processing the message, or if it's a Lambda, the Lambda times out, it cannot process the message in the amount of time that has been allocated to that Lambda from its configuration point of view, you know, where you haven't provisioned it with sufficient memory. Whatever the cause, what happens if the message has not been delivered from SNS to the subscriber? Well, surprise, surprise, the SNS will retry delivering the message a number of times, and eventually it gives up. And what I'm showing you here is a screenshot directly from the documentation, actually. And it kind of breaks up as to how SNS behaves in terms of delivering messages to subscribers. It depends on what who the subscriber is or what type the subscriber is. So what this table is telling us is that if the subscriber is Kinesis, which we haven't looked at, or Firehose, which is linked to Kinesis. So we're not really interested in this part of the table. Clearly, we're interested in this part of the table here. And that includes this stuff, right? Excuse my drawing. I should have actually included that, sorry. So it looks like, I'm just going to clear that because it's a bit, let's see. Yeah. It looks like that it will retry 3 times without any delay. So if it tries to deliver a message to either a Lambda subscriber or an SQS subscriber and the delivery fails, then it's going to retry 3 times without any delay. If it's still getting failures, it'll try 2 more times with a second between each attempt. If there's still failure, then what happens from then on depends on what the nature of the failure is. If the failure is happening because the subscriber is busy, then it follows what's called a back-off, an exponential back-off approach towards retrying. And the specifics are here, right? It tries 10 more times, but it increases the gap between each retry using this exponential back-off algorithm, which I won't go into. And it even keeps on going on further. If after that 10 attempts, it's still failing, it looks like it just keeps on going for quite a period, actually. So it doesn't give up easily. Now, I can demonstrate this. So that's where, if I go back to my code, and if I look at the Lambda that's directly subscribed to SNS, which is this one here, you can see I'm just kind of artificially causing a failure to happen. So it looks like I'm checking my message to see, is there a name attribute in the source message that was sent to me? And if there isn't, then throw this exception. So if we try and send a message to our SNS topic, and we're only interested in this Lambda here now, and the message does not have a name property in it, then let's see what happens. So I've got another JSON file here. Oh yeah, there we go. So this little JSON structure now will satisfy what I'm trying to illustrate. Oh, I tell you, I can just undo that. And now I can switch branches. Okay, got there. So if I look at my stack now, there are a number of new elements to it, but we can kind of ignore some of them for now anyway. So I still have my topic. I still have my queue. I have a second queue now, which is going to act as my dead letter queue. I still have the Lambda that's subscribed directly to my SNS topic. I have the Lambda that's listening or polling the SQS queue, which is this one. I have a Lambda that's going to deal with the messages that are put into the dead letter queue. And here I'm adding my various subscribers, and I still have only 2 subscribers. I have my Lambda subscriber. We can ignore these configuration options for now. I have my SQS subscriber, and I have my event sourcing. I have to connect my Lambda that's polling the SQS queue. That's what I'm doing here. And I'm also I am connecting the Lambda that's polling the other queue, the new queue that's that will have faulty messages in them. Okay, let's redeploy that. So what I want to demonstrate to you is essentially this retrying that SNS will do of the Lambda that's directly subscribed to it, because I'm going to be sending a bad message into my SNS topic, and when the Lambda subscriber receives that, it throws an exception, which is simulating my kind of failure. But the SNS will keep retrying to send it'll keep trying to send the message, even though it is sending it to it, but because the Lambda is failing, it doesn't know obviously why it's failing. It'll retry a number of times, and I think it's 5 times, and the 5 comes from the 3 retries that it does here, plus the 2 that it does here. But because my Lambda is not failing because of a throttling error would be if the subscriber is busy, but that's not the case, because multiple concurrent instances of my Lambda can be spun up. So it's not a throttling issue. And so because it's not getting a throttling response, SNS will give up after 5 attempts. And so, but then what happens to my message, and what I want to happen to my message, is I want it to go into a dead letter queue. Now we'll deal with how we configure the dead letter queue in a moment, but I just want to prove the 5 retries that SNS will try and do. So my stack is deployed, and in this case, I want to send the bad message. Okay, and send my message. So the message gets delivered, and if I look at I'm only interested in the log stream from the Lambda that's directly subscribed, because that's the one that's failing. So if we go into this one here, it has tried it only once. The log streams can delay a little bit. So it looks like it's only done it once here, but if I refresh, no, have I done something wrong, I wonder? So what I should have seen happening is when I looked at the log of see, where's my architecture? This is my architecture. When I looked at the log of this Lambda here, because it was throwing exception, which should have caused SNS to retry sending the message, and the console log would work every time the Lambda was retried. The console log statement would appear okay in my log stream because the exception is thrown after the console log has been executed. So in the log stream, I should have seen 5 attempts at running my my Lambda function, and the 5 comes from that table that I had there a few moments ago. And then because the Lambda is failing through causes other than the Lambda service is too busy, if a receiving service is too busy, what it returns back to its invoker is what's called a throttling response. essentially saying, I'm too busy, try again later on. But it's not a throttling response that the Lambda service will be giving back to SNS. So in terms of my table that I showed you there, SNS would give up after it had completed this number of retries. It wouldn't get into doing 10 more retries. So I would have expected to see not 5 log streams, but 5 attempts at running the same Lambda VM instance. But I wasn't getting that, obviously. And I think I can redeploy now. And really, if it doesn't work here, I'll have to plow on. So we can see this time now, it is throwing the exception, which I wasn't getting the last time. But that should have caused SNS to retry it. I think it's working this time. So you can see it ran it once here. And, or did it? Oh yeah, it's running it a second time here. And if I keep refreshing, eventually it'll come up to 5 attempts. Now, the delay really is not so much on the SNS and Lambda. I think the delay is happening on the CloudWatch log side of things. These should be updating quicker than they are. But at least we can see that my Lambda is being invoked multiple times so far. Let's see how many times. It has, oh my gosh, why am I getting one? Oh yeah, I'm getting 5 actually. You can see there, I've just done a search. Sorry, no, I've done a search on start. Start is, I get start here in the log at the beginning of each execution of my Lambda handler. And you can see here, I've got 5, if you can read it, I've got 5 occurrences of start occurring in my log. And that tallies with the 5 invocations that SNS tries to do on my Lambda before it eventually gives up. Sigh of relief. I don't see 5 on the screen now, but it's giving me 5 and it's telling me, sorry. Right. So you can see anyway that there are a number of attempts at invoking my Lambda, and whereas the first one is a cold start, as evidenced by that, the other ones, like this one, let's see, there's another cold start there. Actually, it's kind of unusual. This start here is a what we call a warm start. In other words, it's using one of the micro VMs that it has already spun up here, and so on. So it gave up after 5 attempts because it wasn't getting a throttling error. It was getting a something other than that, let's say. Right. But we don't want to lose the message that it has caused my Lambda to fail. We'd like to debug it some way, and the typical way we do that is we provision a DLQ. So how do I provision a DLQ for this particular scenario? Turns out there are two ways of doing it, and as is almost typical of this lecture now, when I was preparing this, one way I got to work, the other one I didn't get to work. So I'll show you the one that does work for me. But the objective anyway is after, in our case, after the 5 attempts have failed, then we'd like the message to be put into an SQSQ and have another Lambda handling, dealing with that. What else am I saying here? Yeah, I mean, you see, the problem is that SNS invokes my Lambda, but it does it asynchronously, which means if you look actually at my Lambda code, it's not returning a response back to the invoker, because in this case, the invoker is not really waiting for a response. It's an asynchronous communication. So that's part of the problem. But so SNS does not wait for a response. And so it's up to Lambda, to the Lambda service, I guess, to handle error scenarios. And as I've already indicated, we employ a DLQ to do that. So sorry, no, there's part of that. Oh yeah. So this is what I want to achieve. I have my client, my SNS, my Lambda, but the Lambda will have a DLQ, which is an SQSQ, and I have another Lambda that's dealing with the messages that are going into that. So how do I kind of form this connection here for this particular scenario? If SQS, if it was SQS that was here, then I would connect SQS with the dead letter Q, and the SQS service would take care of putting faulty messages into my DLQ. But now the Lambda service has to do it. And so the way I do it, or a way of doing it, is by means of this configuration down here. So it's part of the configuration of your Lambda instance. And you can use this configuration for other scenarios other than the one that we're looking at here, the kind of SNS with a Lambda subscriber. And basically, as is kind of obvious enough, I suppose, from the name of the property, if my Lambda, on the occurrence of my Lambda failing, but it's after a number of attempts of trying to get it to execute, on the failure, on recurring failures, then eventually what I want is, in this case, I want the message to be put into an SQS destination, as it's referred to in this terminology. The destination actually can be anything. In my case, it's an SQSQ, but there are other types of destinations as well. I think you could have it go into possibly a database, but there are other types. So, and we can actually, we already have that working in the demo that I've just ran, because we have a scenario where our Lambda is failing after a number of attempts. And in my code, I go back to the stack file. I have this queue here as my dead letter queue. The other queue is just the queue that's subscribed directly to the SNS topic. So this is my dead letter queue, but it's just an ordinary SQS queue. And as I've already shown you on the slides, here is the Lambda. Here's the Lambda. Well, in fact, I had it disabled. So can I go back to about all the place today? Let's see. Let's go back to the log groups. Let's do a refresh. Okay, so my dead letter queue wasn't active at all in this scenario. So I've essentially kind of lost the message, if you like. But if I now bring in this piece of configuration, I enable this. If I redeploy, I'm racking up my costs here now. If I redeploy, and that's the only thing I need to do, I think. Yeah, if I redeploy. And while it's at that, as you may already have picked up, I have a third Lambda that's at play here. And this is the Lambda that is triggered by messages going into my dead letter queue, which I have affected from here. And the Lambda itself, again, doesn't do anything interesting. It just does a console log. Here it is here. It just does a console log of the message that it gets, messages, strictly speaking, that it gets from the dead letter queue. I just think I might push on because I've lost time, obviously. But when I send a faulty message to my SNS topic, then I should see 3 log streams appearing. The log stream associated with the Lambda subscriber, the log stream associated with the Lambda that's connected to the, let's call it the ordinary SQS subscriber to the SNS topic. And I should see a third stream, which would be the Lambda that is processing the messages that have been put into my dead letter queue. Because anything else has worked for me so far. Let's just try and send that message, and I should see 3 eventually, because there are time delays when SQS is involved. I think I put in a 5-second delay in terms of the polling that's done. So far so good. So the Lambda that's linked to the ordinary SQS queue is this one here, and the third log stream is going to be a little bit slower because we now know that SNS is going to try the Lambda subscriber 5 times before it eventually gives up. And it's only then that the message is put into the dead letter queue, which will eventually trigger the Lambda that's processing that queue. Something you can do with subscribers really is have filtering, and you can configure the filtering. So what the screenshot is showing us is we've got different types of messages that have been put into my topic, and they're just color coded to illustrate this. And I've got various subscribers here, which happen to be SQS queues, but it's not specific to SQS subscribers. But I want to do some filtering. So it looks like this subscriber, it wants to receive all the messages, whereas this subscriber is only interested in the ones that are yellow and whatever this dark blue is. This subscriber is only interested in the red messages. This subscriber is only interested in the yellow messages. So the filtering is actually something that you configure in terms of the subscription. So how do we actually achieve that? Surprise, surprise, I've got a demo of it. And I'm just showing you in this code screenshot. It's just a property that you set on the subscription itself, on the subscription registration, if you like. Now, there's quite an elaborate syntax. It's kind of a declarative syntax available to you, because the way you declare the filtering can be quite sophisticated or simple, depending on the nature of the messages, I suppose. I should say that there's two types of filtering that's available to you through this mechanism. There's what's called attribute-related filtering. As well as a message being sent to an SNS topic, you can associate attributes with that message, which is separate from the body of the message. And you can do filtering based on the values of some of the attributes associated with the message. What you can also do is filtering on the basis of the actual message body itself. That's quite tricky to program, and I might have an illustration of that for you next week. The attribute one is easier to illustrate. If I just go back to here. Okay, so back to our earlier demonstration, we can now see that there are 3 log streams here. So the Lambda that's processing the dead letter Q, that has been triggered as it should have, because I did send it a bad message. And that's this log stream here. Okay, let's go back to our filtering. So I have defined some filtering, and just arbitrarily, I've decided just to demonstrate it on the Lambda that is subscribed to my SQS, to my SNS topic. And so if we look at this here, and now enable this, I'm saying that the only messages that should get through to my Lambda subscriber are messages where they have an attribute where the key of the attribute, because the attributes is an object structure, kind of a JSON structure. And the way you interpret this filtering declaration is, I'm saying only messages that have an attribute named user_type, and where the value of that attribute is a string, where the value is it's a string-based filtering, and the value of the string has to be equal to the string student. And there are other kind of options available too. So in this case, I'm just saying I'm specifying my filtering based on what is allowed through. You can also specify what messages are allowed based on a kind of a denial list as well. I might have examples of that maybe next week. So I need to redeploy, obviously. Now, in terms of putting a message and associating an attribute with that message, from the CLI point of view anyway, there's this property or option that's available to you, which allows you to set attributes on the message, and you give it a JSON structure. So you can see here, I'm giving it an attribute that matches my filtering. The way you specify the attribute is quite long-winded. You have to give the name of the you have to give the name of the attribute. You have to say what type the attribute is. The types are string and number. I think they are the only 2 options. Maybe object is another possibility. And okay, so you're saying its type is string value, and then you're giving it an actual value. You're giving that attribute a value. So it's quite clumsy the way you specify attributes from the CLI point of view anyway. Okay, so my stack has deployed, and now I want to change this because it's a different ARN. So let's supposing I set the attribute to, the filtering says that it will only allow the message true to my Lambda if the attribute value is student. But let's supposing I set the value to something else. Let's say I set it to lecturer. And I'm going to send the same message as before. So it's just the structure with a name, email, and whatever else, address, I think, wasn't it? Okay, so copy this bit. Now, what I should see, because I've set the attribute to something other than student, I should see a log stream for the Lambda linked with the SQS subscriber, but I should not see a log stream associated with the Lambda subscriber, because it's the Lambda subscription that has the filtering associated with it. Yeah, it's my Lambda subscriber, and my Lambda is this guy here, the process SNS message. So I should not see a log stream for that. What's the chances this won't work? Have I cleaned up my log streams? And there's no delay on that log stream appearing if the Lambda is triggered. So it would appear straight away if it was triggered. There's my message gone through, and I'll just give it 5 seconds or 6 seconds, and then I will see a log stream for the Lambda that's linked to the SQS subscription, and that's the only one I'm going to see, because the message is it's a good message, so there's no dead letter Q or any of that coming into this demonstration. Do a refresh. So yeah, this is the log stream for the Lambda that's processing the message on the SQS queue, but I'm not getting the process SNS function log stream appearing at all. And if you don't believe me, which I wouldn't if I were in your situation for this lecture, just do a refresh to confirm it's definitely not going to. Yeah, so that Lambda has definitely not been triggered. But if I now resend or send another message where that property is set, which I'll do here. And there we go. So the log stream has appeared this time because the filtering let it pass through to the subscriber. Okay, so that's filtering based on an attribute of the message. The message could have other attributes, but we're just specifying particular ones that we're interested in. And this attribute stuff, the attributes are always there, whether you're using filtering or not. So the screenshot is showing you the console log of the message or event, if you like, that reached my Lambda subscriber. And you can see down the bottom there is where we can see the attributes attached to the message. Previously, that would have been an empty array or an empty object, I guess, actually. So that's that. As I said, filtering on the basis of the message body is a little clumsier and I might try and get a working example of that for you next week. Now that's as much as I want to talk about in relation to SNS. How are we doing on time? Okay. So in general, what we're talking about here is we want to avoid synchronous communication between compute components that make up our stack. In our case, that would be Lambda components. We don't like Lambdas communicating synchronously with one another. We try to decouple them. And so we have seen two mechanisms that we can use to decouple components, SQS and SNS. So they're ticked off my list. And the third one here is something called data streams, which is, it kind of falls into that same decoupling situation, or avoiding a synchronization situation. It's slightly off center, but I'm putting it into the same area. Now, this is a slide that we had way back when I started talking about the serverless model and how Lambdas, that's when we started talking about Lambda, because Lambda is the compute serverless option, or one of the compute serverless options provided by AWS. And when we were talking about Lambdas back then, we said that there are three ways that a Lambda function can be triggered. It can be triggered synchronously, asynchronously, or the third option, which is kind of the odd one out, is it's an event source. There's an event source mapping associated with it. In other words, the Lambda is polling the event source for events that would cause it to execute. And where this event source or this polling model comes into play is when you've got either DynamoDB streams. There's also Kinesis streams. Even with SQS, the communication between a Lambda and an SQS queue is based on this event source model. As you might recall, when I was talking about SQS, the Lambda service polls the SQS queue for messages. It's not that the SQS initiates the communication. It's done from the Lambda side. Now, a similar polling mechanism happens when you've got what are called DynamoDB streams. And so the picture on the right is trying to demonstrate this, where let's supposing you've got a DynamoDB database and you've got some mechanism for making changes to that database, whether it be updating items, adding new items being records. Here I'm just showing it directly coming from some other client, but it could be a Lambda that's making the changes to the database. And we want another Lambda to be invoked whenever there are changes made to items in my database. And the way we get that communication to happen is by defining what's called an event source between this Lambda and a DynamoDB stream. Essentially what happens is DynamoDB sort of keeps a log or a stream of all of the changes that occur within a table. That's provided you've configured the DynamoDB table to do that. So the stream is being maintained by DynamoDB, but the triggering of the Lambda is handled by the Lambda service, and it essentially polls the DynamoDB table, asking it for, are there new entries in your stream that I should pass on to this Lambda function? So how do we set up this link here? And I suppose, let me just show you. Yeah, I'll actually cover it next week. I don't want to get stuck into it now, really. I should have if I didn't have all of those problems delaying me, but so be it. Okay, so I'm going to pick up the story, and it's really, there's only these couple of slides. Yeah, that's really all I need to cover on this topic, and I'm essentially finished the module at that stage, although I might try and have a a working example of filtering based on the message body to demonstrate next week as well. And of course, there is that small issue of the second assignment that I had to talk about next week. Okay, I'm going to wrap it up. And apologies again for the glitches, but there you go. Just in case there are any questions, I'll pause for a minute. No. Okay. So I'll talk to you again next week. Bye-bye.